Alright, so I wanted to, working on this level here, right, where basically, I have to make, I have to make a circuit that copies from any source to any destination, and the instruction for what source and what destination is determined by an 8-bit, or a 1-byte input. So I started recording because I've kind of started to get this figured out. It took me a little while to get to this point, but basically what we've got going on here is these 3 bits in this 1-byte input determine which register to load data from. So there's 6 registers and input from basically somewhere else, I guess, hypothetically. And so given the combination of what bits are live here determines which register to load the data from. So pretty simply, all you need to do is just, spread out your 3 bits that control it, and then for each instance, like for example, when we want to load from R0, none of these lines are on. So when none of these lines are on, we want to load from R0. So we use a gate, which when all 3 inputs are on, it gives an output. And since none of these inputs are on, we want to flip those bits with a NOT gate so that when they're all off, this line goes live, loads from register 0, and then basically this is a bunch of switches hooked up in a combination that, like, say when R0 is on, we need to be on input 1 on this switch, input 1 on this switch, and input 1 on this switch, and then it kicks it out to, I guess you'd call this like a memory bus or something. And so for all of these given states, I have it hooked up. So like, let's turn on R1. So now R1's on, and that switches this switch to state 2, which loads input 2. This one stays at 1, this one stays at 1, kicks that number onto the memory bus. So now we've got that set up for all 6 registers and the input. So now I gotta figure out how to do pretty much the same thing for the output. So now we know what register we're copying from. Now we need to program it to know what register it's copying it to, or which register should save it is an easier way to think about it. So I'm gonna pretty much do exactly what I did here. I just need to figure out which bits are my output bits. So the 1, 2, and the 4-bit are the output bits. So let's grab a different color, and let's just bring these down here. Need a little more room. There. So I like to lengthen these wires so that I have ample logic room, I guess you'd call it, to worry about how to make your circuits. So we're going to be messing with the 1, 2, and the 4-bit, which is this one, and this one. So now we're just going to go through. So when we want to save to register 1, this line is active. So we're going to grab an AND gate, which AND is only on when both inputs are on. Same thing with the 3-pin, which is just 2 of these arranged like this. So once all 3 of these are on, this will turn on. And we're going to need 2 of these because we want to be loading from register 1 when this line is on and when these 2 are not on. So, whoops. We'll connect it up like this. So now you can see that this gate is on, but if I toggle any of the other bits, it shuts off. So that's R1. we're gonna move that down though, because register 0 is up here. And we want to kind of place things in order here. So same deal. When all of them are off, we want register 0 to save the value. So we're just going to use 3 of these because all the lines are off. Boom. Now this is on. So now you'll see if I toggle any of these bits, that one shuts off. So that's good. So let's see. On this register, the save function is that input. And now if you're wondering how these registers work, hold on. I know I made one of these at some point. Saving bytes, yeah. So this is basically that register, and the other level is this. And these bits here is a... So basically all a 1 byte register is 8 1-bit registers and a couple of inputs to tell it to save or load. Now a 1-bit register is... Let's see, where did the bus, saving verse, there we go. So this is all a 1-bit register is. It's just 2 AND gates, an OR gate, and a delay line. So basically, how that works is it energizes the line when you want to save it, and then even after you toggle it off, basically this kind of works like a redstone clock in Minecraft. When you turn this on, it comes back around until you tell it to not save it anymore. Either way, so that's a 1-bit register, and then that goes into the 1 byte register, and then here we are now. And so you can kind of see how this game works you up to places. So that's all of that work is in that little guy right there. And we've done similar things for all of the components here. So now we're saving the value to R0. So we're going to hook the register up to the save value bus, or the memory bus, I guess. We're going to hook them all up to that. We also need to hook up this output. So now all of the registers in the output are receiving the same value on the memory bus all the time. What we're deciding is which registers save that value and which registers load their value. So right now, with the instruction set that we have given to us, which is copy from R0 and save to R0. So like we explained before, we're loading R0 with this circuit. So that value from R0 is on this line, and now given these inputs, we're saving that same value to R0, which in this case is it's all 0 because we haven't moved the circuit through any ticks yet. But that's basically how it would work, and we're just going to do the same thing for each register and output. So that's our 1. Alright, so when this line is on, we need to load R2. So same deal. If it ain't broke, don't fix it. Just an AND gate and some NOT gates. So that's our signal to save R2, which is this guy down here. Now we're going to go to R3. So those 2 lines are on. So when these 2 lines are on, and when this one is off, we're going to save R3. Alright, how do we get to R4? Okay. So when that line's, when that line's on and these two are off, we're gonna save R4. So now we need R5, which is these two. So when that one's on, and when this one's on, and when this one's off, we're gonna load R5. Alright, so that's that sorted out. We've got one more combination though, and it is output. We need to figure out how to toggle output. There we go. So, same deal. And that's live. And that's live. And that's dead. We are going to toggle the output. So we've got our input state set up, our output state set up. I think that's all we're gonna need. So let's run it through some ticks and see if it's working properly. Already not working properly. So we need to be taking the input, the value from input, and sending it to output. So the problem we are having is that when we're set to input, this switch needs to be toggled on so that we're reading from output 2. So really what all that needs to happen is this wire needs to connect to this wire, but that causes a short. So we're just going to use a gate. Excuse me. So now hopefully it will actually load 63. So we're going to be copying input 27 to register 0, which it seems to have done that. And so let's do a couple more by hand. Copy register 0 to register 1. It worked. Alright, I'm just going to run it because there's probably 100 different combinations. There we go. So we have now created a circuit that basically we've created a memory chip with 1, 2, 3, 4, 6 bytes of capacity. And so you could iterate this all the way up to, you know, sky's the limit. You're just going to need to, it's going to get infinitely more and more convoluted, not complex, because the same basic principle applies. We're just going to have more switches, more switches, more switches, and a lot more combinations. Could absolutely still be done with low-level logic by hand. And I'm certain that there's probably ways I could have done this using more of 8-bit logic. But for me, it's a lot easier to understand if I split the 8-bit logic back into 1-bit and worry about my states in that manner. But yeah, that's all done.